So I just don't have some time now, so I'll try to solve one lead code problem live. So let me see how fast I can solve it. I'll admit I have some idea how to solve this problem. I'll maybe explain you the solution idea that I have. If I am able to pass this problem. So I have not really practiced C++ in quite a while. I mean C++ in the competitive sense for quite a while. So let me see whether I can pull it off. So let's get started. First, let me find the length of this, right? So I'll do how to find int n equal to num size will be dot size. So this will give me the length, and for it's trying to find the sum of all the numbers. Uh, I plus plus. I need to define a variable called sum first. So int sum equal to 0. This is all very simple. Sum plus oh, plus equal to nums I, right? So this question basically wants to calculate the to divide a particular array into two equal half subsets. So for that, the array should itself be divisible by two, right? So the sum should be divisible by two. So if sum not equal sum percentage two, right? Percentage two is not equal to zero. So then we should return false immediately. Otherwise, we will carry on. So we'll define a DP array. We'll do use this in a DP array. I don't know how to define a DP array. Is this the way? DP. I think this should be the way. I'll just define I think sum. I think I should probably define a variable which stores half of the sum. So int target equal to like sum by two. Okay. So dp will hold one more number because we need to get to that target. So I'll explain you like dp what it is. Just let me code. I could iterate through all the elements. Okay. And then for each iteration what we'll do is that we'll try to populate the dp to the best that we can. So what we'll do is we'll take for int j equal to target. Okay. J greater than equal to, it should be nums I, right? And then obviously j minus minus. So for this what should we do? dp of j should be equal to dp of j and or dp of j minus uh, num psi. Is a very beautiful problem with a very short solution, right? So and then at last we should just, I guess, return dp of target, and that's it. I think that should run. Let me like first run this program and see what happens. So it is, I think, passing the cases. So let me submit it. Wrong answer, right? So which case is giving wrong answer? Where did I go wrong, man? So I need to debug it now. I must have done some mistake somewhere. Oh, I should initialize. I have not initialized. Like I think I should first. I should give an initialization. dp zero should be equal to zero. I think now it should work. Right. Run and then submit. Still, it is not working for some reason. Have I like? I think I should initialize everything to zero initially. Uh, go set everything to. I think dp zero should be one. I guess because I want this to be true. So dp zero should be one. I think, and then for int I equal to 0, I sorry not I equal to 1, I less than equal to target, I plus plus, this dp of I should be equal to mm, 0. Okay, so this is how it should work. Should int gives a problem or I don't know. This is some, I think I'm struggling with some language issues here. Not really. I don't think this is. So I was able to solve. So this was the issue. Like I had to like, because initially we don't know like for what is the condition for but basically what DPI means. Let me give you an explanation. So DPI basically means whether we are able to create a subset which sums to length I from the current elements. Okay, so matlab on the current array, whether we are able to create a subset which sums to I in from the current array. That is what DPI represents. So we are trying to populate DPI, and we try to populate DPI based on the information till we have till sorry beg my pardon, I'll repeat myself. We try to populate DPJ here for this loop, uh, which where j gives the whether the subset exists whose sum is j for every for every element. And basically for one iteration what it means is that if we have looked at the ith element, and by looking at from 0 to the ith element, right, what can we say about what can we say about this dp, where each dpj corresponds to whether there exists a subset which sums to j, right? So in order to explain this, let me just show you in excel. So see, if we have a simple like a simple set, right, this is a simple four element array, and for I you see what comes out. If using the same procedure I comes, you can see this is what happens in the over the iteration, and we can say dpi is true. DPI means true means if we have looked at 0 to 0, basically that is what it is in this case, then we can say that there exists a subset which sums to 1. So that's why DP1 is true. So as we go on for if you for I equal to 2 in which source value of 2, we can see like after the iteration we can say that there exists subsets which has length which can sum to 2 if we have looked at only the zeroth and the ith index element of the array, which is true because if you take the only the I equal to 1 index, then obviously its value is true. So if a subset comprises only of it, so the sum of the subset will be true, hence dp2 here is true. And if we take both the zeroth and the 1th index elements, then the sum will be 3, which is correctly indicated here, which shows dp3 is a 3, which indicates that 3 sum is a possibility. uh, 3 sum a subset is a possibility of this array. This is again reiterating my statement. Looking till here, it is looking at only the zeroth and the first index of the array. So after completion, after going through all the indexes, we will be able to find if the deep if the such a subset exists which has a sum of sum which sums to a sum of target. And if you remember, target is basically what I did. I got target by doing this what is this target? Target is sum by 2, right? So if you are able to find a subset which sums to half of the sum of the entire array, then obviously half also exists, and hence we can partition the entire array into two equal sum subsets. So this is what solves the problem. I just did some live coding. This is something different that I did. I'll just post a direct video on LinkedIn of this. Okay, thank you. I'll see you in the next video.